So hello everyone, welcome back to another particular lecture series of our Reagent Chemistry course, and this is the class 23. And in our previous discussion, we are starting the oxidation. So this is the oxidation of alcohol, and in this particular class, we are talking about the Jones and Collins oxidation in details. So first of all, in oxidation of alcohols, there is a mainly three types of oxidizing agent are there. One is the chromium-based oxidizing agent. And under chromium-based oxidizing agent, there is a Jones reagent, Collins reagent, PDC, PCC, and PFC are there. In the case of Mn-based oxidizing agent, MnO2, MnOAc2, and Ba2MnO4 is there. Out of which the MnO2 are the most important in the manganese-based oxidizing agent. And also there is a DMSO-mediated oxidizing agents are also there, out of which is the Swan oxidation, Kodekim oxidation, Moffat-Pitzer, and many more oxidation are there in the DMSO-mediated oxidizing agents. Okay, and there is other reagents are there as well. So basically, oxidation of alcohol, what is the meaning of oxidation of alcohol? Oxidation of alcohol means that alcohol initially transferred to aldehyde and followed by more oxidation, it is coming in the acid. So this is the overall scenario of our oxidation of alcohol. So let us begin with our discussion with Jones reagents. So it is the chromium-based oxidation, then the Jones oxidation. The combination of CrO3 and sulfuric acid is often referred as Jones reagent, and the oxidation of alcohol with this particular reagent in acetone solvent is called the Jones oxidation. So this is the typical reaction like Jones reagent. This is the alcohol. Now, in presence of Jones reagent in 0 degree temperature, it will become aldehyde. However, in the room temperature, Jones reagent shows uncontrolled oxidation where the particular alcohol is directly converted to their corresponding acids. So here it is written that in room temperature, Jones oxidation shows uncontrolled oxidation. That means that directly alcohol to acid transfer takes place. However, in low temperature, it will show control oxidation. And since this particular reagent, Jones reagent, contains sulfuric acid, that's why this particular Jones reagent is not useful in presence of acid-sensitive functional groups. This is a very much important thing that you have to remember that thing. Okay, so now let us understand the Jones oxidation mechanism. So, first of all, let us understand the reagent. The reagent of Jones oxidation is CrO3, chromic trioxide, and H2SO4, or K2Cr2O7 plus H2SO4 is also used as a Jones oxidation. Now, in aqueous acid, CrO3 forms chromic acid, which oxidizes the alcohol to the carbonyl compound. So, let us see the mechanism first. So, initially, this is the chromic acid that is generated in presence of H2SO4. Now, what happened? Then this particular oxygen lone pair will attack in the chromium, and then it will do a certain rearrangement to get chromate ester, and it looks like this intermediate. So after that, what happened? Then this one of the oxygen is actually captured this particular hydrogen here, and then this particular bond goes there, and the particular chromate ester breaks apart, OCR bond breaks apart to get this particular ketone compound, and this H2CrO4 is the byproduct. And interestingly, Jones reagent is only be able to oxidize an alcohol if it contains at least one hydrogen here. That means tertiary alcohols are not undergo oxidation in presence of Jones reagent. And we can easily explain that particular thing via this particular mechanistic pathway. And if the initial starting material is primary alcohol, then it will be, after oxidation, it will be either aldehyde or acid, depend upon the reaction condition temperature. But if it is a secondary alcohol, then it is always generate ketone. And in case of tertiary alcohol, no reaction takes place, that I already discussed. Now let us see about some examples. Here it is a alcohol is there, secondary alcohol is there. Now in presence of Jones oxidation, it is form a ketone. Similarly here also, this is a secondary alcohol. In presence of Jones oxidation, it will generate their corresponding carbonyl compound, that is ketone. Now let us talk about another particular interesting example, that is another chromium based oxidation. This is called the Collins reagent. Collins reagent is a moisture sensitive reagent, and it is actually controlled oxidation shows because it is a less reactive than Jones reagent. And here, if you see here, the composition of Collins reagent contains CrO3 and pyridine. There is no acid content is there, and that's why the acid sensitive functional group are tolerates in this reaction condition. And this is the structure of Collins reagents. This is the structure of Collins reagents. Now let us talk about certain example. The reaction mechanism is similar, just like the Jones reagent, and the reaction is basically it is also requires at least one particular hydrogen to do the particular transformation. So the Collins reagent also unable to oxidize the tertiary alcohol. So here you can find that this is the alcohol, secondary alcohol is there, so it will reduce to their corresponding ketone compound, and also this type of epoxides containing alcohol are also getting oxidized to their carbonyl compound without breaking the epoxide ring. But in the case of Jones oxidation, what happened? That this epoxide might possibility of breaking because this particular lone pair will attack in the hydrogen or the proton source in the reaction mixture. But in the case of Collins reaction, that thing doesn't happen. So with this, we have to end this particular lecture. So in the previous lecture, we talked about the Jones and Collins reagents in details. So in the next class, we talk about the PCC and PDC mediated oxidation. So thank you for listening.